we have a small crowd, right? So I would love to just honestly run through slides, show you guys a few things, but honestly open up to questions because I think it's nice to do that a small crowd like this. So I'm Matt Pawlowski. I'm the Executive Director of Regulatory Affairs and Business Management for NextEra Energy Resources. I'll tell you a little bit about the company, but the first thing I wanted to start off with is to tell you that I'm here actually as a customer and a supplier. So we are a customer of AWS, and I can talk about what we do there as well. But we are also a supplier of about 2,500 megawatts for Amazon to fulfill their 100% renewable goal by 2025. So pretty proud to be on kind of both sides of the fence. So hopefully tell you a little bit about kind of what we're doing and some of the challenges along the way. So with that, a little bit about NextEra. So NextEra, we're divided into two different companies primarily. There's a lot of other ancillary companies that are involved, but about $140 billion. We are a largest clean energy company in the world. We have two companies underneath there. One is Florida Power & Light, which is one of the largest utilities in the country, regulated utilities, and I'll talk about FPL a little bit. And then NextEra Energy Resources, which is all outside of Florida, mainly dealing with wind and solar, but also getting into hydrogen. There's actually a water business, data centers, all sorts of other stuff that we do there. A little bit about our strategic focus, really focused on keeping costs low, and it kind of goes into two different ways. One is to keep costs low for our consumers in Florida, which is our ratepayers, but also outside of Florida to keep our bills low for customers like Amazon or anybody else that buys clean energy from us. One of the big things that we focus on as well is keeping a very strong balance sheet. That gives us a lot of access to capital, so that's really important, especially when you're building a lot of renewable resources all around the country. You want to have access to the cheapest capital possible. So balance sheet is really important. Again, vision, our vision is to be the largest clean energy company in the world. We're there pretty much right now, but we're not done yet, and I'll show you a little bit about our pipeline and how we're going about our business. And again, keeping bills low, keeping things really efficient and clean as far as output, especially on our Florida Power & Light side. We rely about 70% still on natural gas with a significantly growing solar portfolio there. And again, NextEra Energy Resources, growing portfolio, wind and solar. So I want to kind of break down two different companies. This is Florida Power & Light. So we are roughly, as you can see, now about 6 million customers, all in Florida. Again, one of the largest utilities in the country. As you'll see, that's a territory that's not necessarily the least challenging because we're on the coastline of Florida, so we basically, any given hurricane that comes through Florida pretty much hits us, whether it comes through Panhandle in our Gulf territory or it comes on the East Coast or the West Coast, basically hits us. So rely a lot on technology, a lot on smart meters, doing things like that to make sure that we have a really good system that's reliable. And we've invested a lot into it as well, and I'll show you guys that in a second. On the NextEra Energy Resources side, primarily about 70% wind. We've been one of the largest wind players in the country and the world for a lot of years, but a very much growing solar portfolio that's right now has some challenges that I can talk about as well with some of the Department of Commerce issues, but still the largest player in renewable resources in the world. So we're very proud of that. Batteries are really starting to come online, and then again I mentioned hydrogen and a couple other businesses that we're involved in as well. But about $65 or so billion of total assets that we have at NextEra Energy Resources. So a relatively large company. So our clean energy journey started a long time ago, and we've been on the path of reducing carbon a lot over the years. So this chart really shows you kind of where we started in 2005, which is right around the time that I came into the company. So we were developing our wind portfolio, bought a bunch of wind turbines in California, and that's kind of how things got started. It's been a journey ever since, but we're really proud to be a lot better than everybody else and continuing to even be better along the way. So I mentioned capital investment. Capital investment is very important in our company. Smart capital investment is really the key for our business, since what drives our prices to be low as possible and to be most efficient. This chart actually shows you that we're one of the largest capital investors and deployers in the world. This is amongst all companies in the U.S. And all companies on the stock exchange. So we're number 5 with about $15 billion in 2020 invested of capital. So it's pretty significant. We've also been developing sites for one of the longest periods of time for any developer. So about 20 years or so we've been developing renewable resources. So it gives us a lot of expertise. But the area that I wanted to hit on, which is really important as well, is our analytics. So we think that the scaling and the programs that we put in place are really, truly important. And that's what drives our efficiency, and that's what provides the value to our customers to keep the wind turbine spinning and the solar panels producing as much as possible. So you can see that 39 billion operating points per day. I know that may not seem like a lot, especially if you're on the Amazon side, but it is a lot for a utility. And all of that, by the way, runs on AWS. So that's really important as well. Also, on the FPL side, the one thing I forgot to mention is our relationship as a customer of AWS is that all of our smart meter data and all the analytics that's in the field from any of the smart devices that are out there, again, runs on an AWS platform. And we've transitioned that over several years, and it works really well. We're a very happy partner with AWS, and it's really important to kind of how we function as a daily company. So this is a little bit about our pipeline. So we have right now about 18,000 megawatts that are signed as far as contracts go. And this will come in really handy about kind of where I go with this in a second. But this is one of the largest what's called backlogs of signed contracts for any company that's out there. So 18,000 megawatts is a significant amount that are going to be coming online in the next couple of years. So why is it really important? And kind of the purpose of this entire presentation. So the chart on the left is what's happening right now as far as renewable penetration on the US grid. The chart on the right is what's supposed to happen by 2050. So the darker the color, the closer it is to 100%. So you can see that there's going to be a significant change that's already started, but it's going to accelerate significantly over the next couple of years and into 2050 as all these goals that are really centered around 2050 from the Paris Accord and others start to come into fruition. So we have a lot of work to do. It's going to take a significant effort to get there, but the grid is under a significant amount of transition right now, and that work is going to continue as we go forward here. So the whole transition of the grid provides us the ability to have a lot of disruptive changes out there. So just 5-10 years ago, if you put up this chart, wind costs would be significantly higher, for example, than gas costs, and even higher than coal costs. What we've seen over the last 5 to 10 years is the cost of both wind and solar have come down significantly. So now you can compete against gas on what's called a near firm basis, which means that what you're forecasting to get is what you're really going to get as far as megawatts on the grid. But you can start to have parity with other technologies, and that's really important as we go out there and talk to customers, because it's not always about being green and being kind of clean and things like that. It's also about having the best cost profile, right? So if your wind or solar is going to be expensive or your battery is going to be expensive, there's still going to be a hesitation amongst customers to take those products. So you want to have both reliability, you want to have efficiency, but you want the cost to come with it. And by the way, if it's green, it's just that much better, right? So what you're seeing is a pretty significant shift right now in the cost, which is driving a lot of customers to go to products like wind and solar and others. So pretty interesting transition that's coming along the way. But again, it's kind of feeding into the entire transition of the grid into a more clean portfolio. We've actually put this chart up on our last investor conference. It's actually pretty interesting. So we think that 2050 goal of actually going pretty much all electric on the grid and being carbon free is about a $4 trillion opportunity for generation. That's just generation alone. So how we get there is going to be, again, very challenging, but it's a significant investment and a lot of money that are going to have to come out from all the investors, customers, and so on to get there. On top of this, and I'll talk about this in a second, but on top of the $4 billion just for transmission, just for generation, there's probably about $4 billion in there as well for transmission. So in order to put all this clean energy on the grid, you need a lot of transmission to be built. We estimate that's about a $4 trillion opportunity as well. So again, kind of full economy decarbonization by 2050, about an $8 trillion investment. So if you think about that, that's a lot of projects put in ground, that's a lot of steel being put out there, a lot of government kind of policies and other things that have to align along the way to make this all happen. So, one of the biggest things, and the thing that I wanted to discuss with you guys today, is one of the biggest challenges to us right now is that you have to put all these resources on the grid. So for years, kind of the traditional interconnection process was a utility would build a natural gas plant or a coal plant, and then they would go 5, maybe 10 years, let the load build up, and then build another plant. So there wasn't a lot of things in what's called interconnection queues. That's changed significantly because now there's no longer a 1,000 megawatt gas plant. There may be 50 megawatt solar plants or 50 wind plants or so, 50 megawatt wind plants. So it's changed the game significantly with how you study these new resources that are coming online. Essentially connecting the extension cord doesn't work anymore when you have all these dispersed resources that you have to study differently. What we're seeing is that there is a significant challenge with what's called the interconnection process. So right now, the backlog for the interconnections is about 5 to 6 years in certain areas. Areas like Southwest Power Pool or Midwest ISO, they're experiencing a significant backlog in the way the projects are studied, but also in the transmission that it takes to bring those projects online. So that's been a significant challenge. And there's things that us and others are doing in order to relieve that. But it is a very big problem for us right now that we're trying to solve. So if you want to bring all these resources online, you have to solve this first. Otherwise, you're going to be kind of stuck in the study queue. And that doesn't really help anybody right now. So a lot of other things that are going on between study assumptions and other things that go into the way that these resources are studied to come online. But one of the process right now with a significant backlog is creating a situation where if any customer right now comes to me, for example in Oklahoma, and says, I want to build a project, when can you get it to me? If I'm not in the queue right now because of this 5 to 6 year backlog, probably the earliest that I can tell them that is about 2028. And that's mostly too late for customers. So this backlog and the entire delay in the study process has really significantly shifted the way that we approach how we study these projects and what projects we actually put in the queues and so on. So very big problem. So that's the challenge, right? The title of this was Challenges and Opportunities. This is one of the challenges. And the reason why it matters is, again, the demand for all these projects is greater than ever. We have customers that are coming to us in pretty much every area in the United States demanding these low-cost projects, wanting to put them online as quickly as possible to meet their goals, right? And Amazon is one of those customers, but there's lots of others that we pretty much announce almost every single week, new projects coming online. But they're looking for these projects, again, not just from a clean perspective, but also from a reliability perspective and from a cost perspective. And you need to kind of look at it from that perspective in order to figure out where you're going to put those projects, what's most economical, what meets the needs for those specific customers. So it's going to take a lot of work to get there. But again, the demand is there. So that's why this is becoming a really big issue, because the more these projects get delayed, the less they're going to come online, and the less we're going to be able to satisfy the needs of those customers that are requesting them. So solution-wise, so there's kind of 3 things. I'll start actually with the middle one because I think it's most relevant to this kind of audience, especially with an Amazon Summit. So we have been looking at a lot of technology solutions and actually working with a team from AWS and Amazon to figure out how do we streamline just the study process alone. How do we take these really difficult studies that are very manual right now, put them in the cloud, make them run on standardized assumptions, roll out a process that's repeatable, that's reliable, that we can have for all the different markets and all the utilities in the country, and have them pursue that. And it's been a pretty big effort. We started actually, I don't know how many of you have relationships with Amazon or work for Amazon, but we started this as what's called an executive visioning session. So because we're a large Amazon customer and partner, we brought our executives together and basically had a session that had a bunch of our executives and a bunch of Amazon executives and some directors and others. And we said, okay, what are the biggest problems that are out there? And how can we figure out how to solve them? And this problem of fixing the interconnection process really bubbled up into one of the highest priorities. So we were able to kind of put a team together with both NextEra people and Amazon people and figure out, okay, who do we target first? How do we solve this problem? How do we apply the power of AWS and the power of what we have internally at NextEra and pursue this and essentially sell the concept to some of these utilities and markets that are out there. So that's how this all started. And I've been kind of on an Amazon speaking tour. I spoke at another conference in Houston just recently to a lot of oil and gas executives about this very issue and about how AWS is helping us here. And it's been a pretty interesting journey. But we think that this automation, we think that this technology is really the key to solving a lot of these problems. We have to get these studies done quicker, right? And my joke is that when some of these utilities run the study, it's one guy on a desktop computer, and when he clicks run on a study, he can't answer emails for about 2 weeks because his computer is totally jammed up, right? And that's not really far from the truth, believe it or not. And we think that's just not going to work going forward, right? So it's doing even things like that to just literally speed up the way that the processing is done. Again, it's not really rocket science, but it's something that I don't think has really been considered. So technology is a huge key to all this. The other two, cost allocation and regulatory, it's a little bit in the weeds on policy kind of stuff, but it is really important, and especially if you're interested in this, there's a proceeding right now going on at the Federal Energy Regulatory Commission, what's called FERC, and it's a policy on transmission planning and cost allocation, or what's called participant funding. They're actually going through the process right now to try to fix these issues. And they're trying to fix two issues. One is get the transmission built in time for these resources to come online, which is hugely important because the time frame for actually building out these transmission facilities is 8 to 10 to 15 years. That's how long it takes. And primarily because of all the issues that have to take place with land and site control and all sorts of other stuff. The other issue that they're trying to work out is right now in most areas, when you develop new generation, you're paying for 100% of the cost of integrating that resource, regardless of who benefits, regardless of who has any kind of advantage from those resources coming online. And we think that's, obviously as a developer, we think that's not reasonable. And FERC, I think, is taking the view that some kind of reform is needed to make sure that we align the benefits of these resources coming online and the cost. So this is a really big issue. Again, if you're interested, it's called a FERC NOPR, Advanced Notice of Proposed Rulemaking. It's going through the process right now. They actually just issued what's called a NOPR out of that, which is kind of the next phase, getting really geeky into policy talk. But the Notice of Proposed Rulemaking on transmission planning came out a few weeks ago. I would urge you, again, if you're interested, to go look at it. The next NOPR on participant funding and interconnection reform is supposed to come out in the next couple weeks. So it's going to be hugely important to the industry, and it's going to be hugely important to customers like Amazon and anybody else that's buying clean energy from us, or frankly anybody else. So we've been on a whole speaking tour about this. Again, it's something that's really important, that's a little bit in the weeds, that doesn't get so much attention, but it is very important as we transition for the grid. And the one thing I'll say on not getting attention, there's actually been 2 John Oliver shows, if you watch John Oliver. His 2 shows, one was on transmission planning, it was back in November. I think it was the first time that transmission planning became a little bit cool. And I say that with kind of grain of salt, but the other one came out just recently on utilities and the way utilities function. So it is getting a little bit more attention. There's been a little bit more press around this. There's also been a ton of press, if you're not familiar with it, on the Department of Commerce issue with solar panels right now. What that's done is essentially shut down the development of solar for the next year and a half or so. Department of Commerce opened a tariff circumvention case against really manufacturers from the Asia regions, Vietnam, Malaysia, Cambodia, others, and basically has thrown a gigantic curveball into any kind of solar development because there's no price certainty at all. Until the case gets worked out, the projections on tariff increases can be 50 to 250% on solar panels. And basically no manufacturers of solar panels are willing to take the risk of delivering panels to the United States right now because of that issue. So essentially what you have is no solar is going to get built for a pretty significant period of time. And even then, once this gets resolved, you're still not going to be able to kind of flip a switch and just panels show up from somewhere, because they're not going to show up from the United States because there's really basically no manufacturing in the US. So you're going to have to ramp up, right? So it's going to take a pretty significant period of time for that to ramp up and for solar to start again. We're hoping it gets resolved here in the next couple months. Hopefully by August we get some kind of decision from the Department of Commerce. But again, it kind of feeds into all these issues that are hindering right now the process of bringing clean and reliable energy online, clean, efficient, and cost-effective energy online. So these are some of the things to watch for, but again, I think that the biggest thing that I'm hoping you take away is, yeah, there are a lot of challenges because the grid is transitioning in such a quick and a substantial way, but at the same time, the opportunity is pretty significant, and I think we can really solve it with the right steps. We think we've got it, and we think we've got the great partners to do it. And I think there's no better company in position than to do this than NextEra, and we really count on partners like Amazon to kind of fulfill that need. So that's kind of what I have. I'm hoping that we can, if you guys have any questions, we can cover those. I had my contact slide, but it's a few slides back, so sorry if I'm giving anybody a seizure here. There you go. So, but if anybody has any questions, feel free to shoot me a note or give me a call. So, go ahead.
Here, let me.
Yeah, so you mentioned about you supply the energy to the Amazon cloud platform also. How much percentage actually you're providing for the AWS? Like how many data centers are like?
Yeah, so we have projects right now that supply about 2,500 megawatts. I think, if I remember right, Amazon's full load is about 15,000 or so, if I remember right. So we supply a pretty significant amount to their sites, and it's mostly wind right now. Mostly wind. A lot of it is in this kind of central region of the United States, Oklahoma, Kansas, those areas. So they take that energy and supply their data centers and anything else. So, but it's the difference between Amazon and a lot of other companies that pursue kind of the clean energy kind of structure is that Amazon actually has real contracts. So it's real power. It's not just kind of paper contracts. It's actually a real power that's in the ground that they have access to if they want. So pretty significant amount though. Other questions?
Matt, great presentation. Just a couple questions. The first was on your interconnection study. I'm curious what kind of animal that is. Like, are you actually simulating demand response on the national grid and the quadrants? And then the second part to that question is, are you factoring in the next generation, like nuclear, small modular reactor type acceptable technologies that are going to be out there in 10 years?
So I'll take the first one. The second one first. So yes, the studies are for all the resources that could potentially come online. Now, it's all resources that can be studied in some kind of logical kind of next steps time frame, right? So there's some technologies that are more experimental, right? I mean, you look at like wave or other things. Small modular reactors are probably not in there. They're a little bit more real. But there's a lot of other technologies that are a little bit further out from being cost efficient. So you're not going to have a lot of those in what's called the interconnection queue, where people are submitting to get those interconnected. So the things that are going to come into effect first are the things that are actually in the interconnection queue. There's some great NREL studies if you want to, again, geek out into it, but there's some great NREL studies about what's actually in the queue. There's about 1 terawatt of resources currently in the queue, mostly wind, solar, and batteries. Those are the ones that are being studied. On your first question about what is actually included in the interconnection process and the interconnection study, so at a highest level, what you're looking at is what impact is that new facility going to have on the grid in both the immediate area but also in the farther out area of the grid, right? So if you think about it like a neighborhood, right? So if you build a new neighborhood somewhere, you likely have to build a road to it, right? But there's traffic studies that are done to say, okay, well that neighborhood and that local road is going to create congestion with cars coming on the road. So maybe we need to update the highway or build a new exit or something like that. It's actually the same thing with new generation. What you're doing is you're saying, if I plug this 200 megawatt wind farm in, I'm going to have to obviously get the immediate interconnection close by, that's your local road, but then there may be some other things that I need to do. And that's really kind of the transmission planning aspects of it, is you want to start to plan out so that you're 5-10 years ahead as much as possible on building out those facilities that are going to accommodate wind resources, solar, gas, anything else that are coming on the grid. So kind of multi-part kind of study. But it gets, the models are pretty complicated. But again, if you're running in kind of sequential manner and kind of on a desktop or something like that, that's where the issues really come in. So, yeah. Okay.
I've got 2 questions. First one is, I see we go from now to 2050, you're really focusing on growing out basically your business development map moving forward. But looks like you're going to really focus on going after the city-owned street lights or whatever it might be. So basically you're just going to be looking to buy out those, from those street lights or whatever those assets are. That's kind of what your focus is moving forward.
That's actually a smaller part of it. So yeah, there is a focus on buying kind of the demand side of things.
Okay.
So if you buy that part of it, right, you can control it better. So there is a focus on that. But we are, especially outside of Florida where we're not the utility, we are really the supplier. Right, so we are building the large facility, and we really are more utility scale than anything else. So we're the ones with, like, again, the 200 megawatt wind farm, right? So it's not the stuff on your rooftop, it's much more bigger things, right? Bigger facilities. But we focus on the supply. That said, what I think we're really good at is regulated businesses, right? Because we have that economy of scale, we have the experience of running these things with a lot of technology, so we can run them efficiently and cheaply. So what that opens up is opportunities like we just got into recently, which is more regulated water, right? So if you think about regulated water, what's the difference between electric and water other than kind of the commodity, right? You're still metering it, it's still going into the house, you're still measuring what's going through a pipe or what's going through a wire. You can gain a lot of efficiencies by doing that, right? So we have one of the largest smart meter networks in the world. Why not apply it to water, right? And apply the intelligence that we have from smart meters on electric to water, right?
Oh, those are great contracts, don't get me wrong.
Yeah.
Those are great long-term contracts.
Right. I mean, it's regulated, stable, kind of investments.
Every once in a while. No,
Right.
Yeah, very few limited competition, I guess. Well, I appreciate that. The second question is, looking at it and even working in the space, it's really wrapping in, data breaches, cybersecurity, making sure your system can't be compromised, or now you're actually looking at that as a critical asset now. So how are you kind of wrapping in that whole, basically it's a whole business unit almost, wrapping that in as you're going in?
It's a very, and I know we're over time, so I apologize, but hopefully it's okay to keep going. Yeah. So cybersecurity is gigantic. We actually have a whole business unit that's dedicated just to cybersecurity. We happen to own 5 nuclear plants on top of all the other assets that we own. Those have a whole separate kind of importance and complexity that comes with cybersecurity and then physical security too. But cybersecurity is huge. One of the things that we see as a potential benefit is there is a movement to get a lot of these critical systems into the cloud. So if you're able to use, for example, AWS, not that I'm like promoting AWS for the whole time, but the right place to be, right? But AWS has a lot of benefits that come with their fact that they're cyber secure from kind of an overall higher level perspective, right? So if you're tapping into that, you're tapping into their expertise on that. So you don't have to spend all your time protecting your own servers at home. You can just outsource that out, right? And there's been, I think, a hesitancy over the years on trying to put some of these systems into the cloud. Just electric utility, kind of the way they've kind of gone about it. I think that's really changing now. I think that there's a recognition, and a lot of our stuff has moved to the cloud. So I think there's a recognition that it is actually safer, and it is potentially a better solution to do that. So that's the way we've been going about it. But yeah, cybersecurity is huge. And it's, like every day it just gets worse and worse, right? Because of everything that's going on geopolitically. So very big focus. Yeah.
How much of the streamlining effort that you went through for the planning process was focused on how do you build sort of like standards so you can share information not only across NEA but with the developers, the constructors you're working with, but then federal, state, local regulatory units, or how do you create a common standard for information exchange?
We're talking a lot to FERC about that. It's not there by any means right now. So almost every single area has their own. They have higher level. They have a common set of standards. They're like, especially like if you know like NERC reliability standards, there are a set of kind of common standards. But once you go a layer down from that, then it's kind of everybody does their own thing to a certain degree. It causes a lot of problems, like when you start to study things that what's called go across the seam. So if it's between different markets, it creates a massive amount of issues because one place studies it one way, another place studies another way. You have to reconcile those issues, and again, it's just more delays, right? And more cost and everything else. So one of the things, and I'm hoping that will come out in this NOPR, in this Notice of Proposed Rulemaking at FERC, is standardization of assumptions is going to be one of the things they're going to focus on. They've been telling us that that's a recognized issue that they see, so that's what's going to kind of push that to the forefront. But if you have assumptions that are more standard, right, and if you have ways of looking at it so that it's more transparent and available, then yeah, you can do exactly what you said, right? That any developer or any transmission owner or anybody else can kind of tap into a database and see it. Whereas right now, a lot of those studies, the assumptions, everything else that goes into it is more hidden, right? Not available or just not accessible.
Follow-up, is it trying to incorporate like IEC SIM, Common Information Model standards for the physical assets on the grid, and what other standards might there be? So
you're going like to level 201 or 301. So think about this.
Of course.
Which is good. I mean, so yes, the answer is that's where we're potentially going. But it starts even simpler than that, right? So it starts with, and this is one of the things that we're actually working with Amazon on. So you have all these new generation queues that are coming in. Every one of them has to submit data to be studied, right? Garbage in, garbage out, right? That whole concept, right? So if you have garbage coming in, then you're going to have to spend a ton of time studying it or trying to rectify it or reconcile it instead of actually doing the study. So why not get the data right up front? And instead of having developers, for example, submit models for solar panels, you can have the manufacturers provide standard models that are kind of sitting in a database that you can say, oh, you have inverter 1, 2, 3, right? Oh, I have this model, right? And they click it and it's there, right? Very simplified, but again, that's probably months off study times, believe it or not. So we're going to get to that 201 or 301 level, but we're starting at the 101 on simpler things like that. So it's going to help out a lot. So, yeah. Anybody else? Well, thank you for joining. Appreciate it.